In this lesson, we'll talk about different ways to combine functions. We'll start out with some of the usual operations that you're accustomed to, the sum, difference, product, and quotient. The official notation for these is what we call f plus g of x, f minus g of x, f times g of x, and f over g of x. For all of these functions, what we do is we don't really get confused by the notation. We just see that if it says f plus g, it means add the two functions. If it says f minus g, it means subtract the two functions, and so on. The only one is that f over g is not defined if g of x is equal to 0. What we're going to do is we're going to calculate the sum and difference, product, and quotient, and just do a few of these, and we'll calculate their domains along the way. The domains is going to be the intersection of the old domains. Now, if the denominator is 0, you also have to throw out the denominator being 0 for the quotient. We'll do those as we go. F of x plus g of x is just x squared minus 2 plus the square root of x. That's all it is. You add the two together. But the domains need to be taken into account. Now, as we discussed in the first section, a domain means you either have a 0 in the denominator or a negative in the square root as far as what we have to watch out for. There are other cases, but for our intents and purposes, that's all we have to pay attention to. X squared minus 2 is defined everywhere because there's no square root, no zeros in the denominator. G of x, however, is square root of x, and it is not. In particular, x cannot be negative, meaning the domain of that one is bracket 0 to infinity, and that carries over to the whole final answer. Next is f minus g of x, and we get x squared minus 2 minus the square root of x. And the domain is the same. Because it's just the intersection of the two domains, we won't have any change. F times g of x, well, that means multiply them together. X squared minus 2 times the square root of x, which we can write that as x to the 5 halves minus 2 square root of x if we'd like to combine exponents. And again, the domain is bracket 0 to infinity because we're just combining the domains of the two functions. The last one, though, is a little different. Well, the definition taking a quotient is just write it as a quotient, but the domain includes the restriction that the denominator cannot be 0. The domain of the individual functions is just bracket 0 to infinity, but this time x cannot be 0. X cannot be 0, and consequently we really just have to exclude it from the domain. So it's now parentheses 0 to infinity. The next operation is going to be the one that we'll spend a little bit more time on, and this is called function composition. Some of you may have seen this before, and perhaps some of you haven't. But the idea of composition is that composition is how you combine two functions by putting one into the other. It's taking one function, doing the operation, and then taking another function and doing the operation. The usual notation for this is f and then this circle, which means composed with g of x. In practice, we immediately will pay attention to which function is first and just rewrite it as f of g of x, which is usually the words that I say, f of g of x. If we look at these functions, it's a little bit tough to come up with the domains of these, but officially, you look at the domain of the inside function, and then you throw out any values that appear from the composition process. We'll look at this by examples. While we're doing these, we are going to find the domain of the function, but we don't want to spend a lot of time on these in the future. So we get g of f of x, and this is always the first step. Just write out what it means. G with f of x on the inside. We get g of f of x is x squared. So this step now we just plug in x squared for f of x in our notation here. But now we actually have to know what this means. g of x squared means in g of x, wherever I see an x, like right here, I will replace it with x squared. So g of x is square root of x minus 4, but now x is replaced with x squared. And that's it. Now the domain of this function, the inside function was f of x. F of x was fine anywhere. But when I take the square root, when I do g of x here, now I introduce a bit of confusion. X cannot be 0, as you can see. That would make this thing be the square root of negative 4. It also can't be 1 because that would make it the square root of negative 3. It can't be negative 1 for the same reason. But if I put in 2, I get an okay value. And it looks like 2 works in anything bigger. In addition, negative 2 works in anything smaller. So while I just said this out loud, the idea is that the domain is all the values less than negative 2 and including it, or it could be all the values bigger than 2. We could go through the details a little bit more, but I'll assume you guys have domains a little bit, and we're not going to spend much time with these for these particular problems anyway. Next examples. F of g of x. Well, let's write out what that means. F with g of x on the inside, and again put in g of x. It's x minus 4 and a square root. And now we look at the function f of x. Wherever you see an x, you replace it with what's in the parentheses. So I'm going to get x minus 4 in the square root replaces x, and that was squared. So I just get x minus 4. Now that seems to be defined everywhere, but I need to be a little bit more careful. Technically, it's this, the absolute value of x minus 4. And even more technically, g of x was not defined when x was less than 4. Consequently, I actually don't need the absolute value. The x minus 4 is only defined when x is greater than or equal to 4, which means it's going to be the same value without the absolute value. So this is defined from 4 to infinity because those are the values where g of x was defined. All right, next example. Let's write this out. H of g of x. And then plug in g of x. It's the square root of x minus 4. When I plug that in for x in the function h of x, I get 1 over. X becomes the square root of x minus 4. And so for the domain, g of x was undefined when x was less than 4 like we had before. But this time x also cannot equal 4 because if it did, we would get a 0 in the denominator. So it's going to be 4 to infinity for the domain. Again, if the domains are a little tricky, don't panic, it's okay. G of h of x. Let's write this out. That means g of h of x. Let's write it out. And h of x is 1 over x. So wherever I see an x in the g function, I will replace it with 1 over x. So I get the square root of 1 over x minus 4. And this is starting to get complicated enough that I think I'll start forgoing the rules that involve domain. And then finally, h of x. H of x is 1 over x. So here, wherever I see an x, I will replace it with 1 over x. I get 1 over x. Funny looking, but that actually simplifies to just x. And in this one, the domain is easy enough that I can just say it's x cannot be 0 because that was part of the inside function, but otherwise it does work. The last bit here is how do we tackle these when numbers are involved? And it's actually easier when numbers are involved. Let's just write out what this means again. And now, follow your nose. What does f of 3 mean? It means plug 3 in for x in the function. So f of 3 is 3 squared, which is 9. So f of 3 becomes 9. And then all I have to do is plug it into here. G of x is square root of x minus 4, so I get the square root of 9 minus 4. That's the square root of 5. f of negative 2. Write out what it means. F of negative 2 is going to be negative 2 squared, which is 4. So I get f of 4, which is 4 squared, and that's 16. H of g of 5. Well, g of 5, if I plug in 5, I get the square root of 5 minus 4, which is the square root of 1, and that's just 1. H of x is 1 over x, so I get 1 over 1, which is 1. Just plug in the values, calculate them as we go. Once you've done 2 calculations, you have an answer.